Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing bearing and elevation. This video will tackle more advanced problems. There is another video that tackles the basic problems in bearings. So you should watch that first if you haven't already before watching this video. So in this problem, we have a field ABCD on horizontal ground. There is a vertical post at C. From B, the angle of elevation of the top of the post is 19. So let's draw a vertical post at C. And then from B to P, the angle of elevation here is 19. We are required to find the height of the post. So we want to find H. Now, in order to find H, we need to figure out the information we have. So bear in mind that this angle here is 90 because C is on the ground and H is vertically up. And we have this side here, which is 107. So all we have to do is just write TOA tan 19 equals opposite over adjacent. So H equals 107 tan 19. I just cross multiplied as if you did over 1 here. You cross multiplied. So H equals 107 multiplied by tan 19. And that gives us 36.84. With three significant figures, we have 36.8. Let's check to make sure we're on the right track. Yes, the answer to A is 36.8 or 36.84. Now, for B, we are told use the cosine rule to find angle BAC. So never mind the elevation for now. So we just need to use the cosine rule to find angle BAC. Angle BAC is in a triangle, and we have everything given, so this should be pretty straightforward. BAC, we want this angle here. This is 158. This is 132. This is 107. And we want to find angle A. So we simply use the cosine rule. Cosine theta, this is theta, of course, equals 158 squared plus 132 squared. And of course, the opposite side is the negative in the cosine rule. So this would be minus 107 squared over 2 times 158 times 132. Let's evaluate the numerator. 158 squared plus 132 squared minus 107 squared. This gives us 30,939. So we have 30,939 in the numerator. In the denominator, we have 2 multiplied by 158 multiplied by 132 for 41,712. Now we evaluate shift cosine this fraction here. So theta equals inverse cosine 30939 divided 41712. And theta equals 42.12, just 42.1, that would be fine. Again, let's check the marking scheme for B. Yes, 42.1 is the correct answer. Next, we are required to find angle CAD using the sine rule. So let's just put angle 42.1 here. So this entire angle here is 42.1. And we are required now to find CAD. So CAD is the angle that I'm about to mark in blue, this part here. And in order to find that, let's look at triangle CAD. This is our theta. This is 116. This is 132, and this is 86. So we have everything we need in order to carry out the sine rule. So 86 over sine theta equals 132 over sine 116. And you cross multiply. So 86 sine 116 equals 132 sine theta. So you divide by 132 and you cross this out from here. So 86 sine 116 gives us 77, and then you divide this answer by 132. You get 0.585, whatever. And then you do shift sign answer on the calculator without approximation at all. And this gives you theta automatically. Theta equals 35.84 or just 35.8 to 3 significant figures. Again, let's make sure we're on the right track. Yes, so for question C, the correct answer is 35.8. Now I'm going to include that as well on the drawing. So we have 42.1 and 35.8. So let's just put them in. So this here is 42.1 and this here is 35.8. Moving on, in D we are required to calculate the area of the field. So the area is comprised of two sides, of two shapes, excuse me, two triangles basically, triangle ABC and triangle ADC. If we get the area of the individual triangles, we can just add them up and find the total area of the field. So how would we do that? For the first triangle, we already have this angle here, 42.1. We have 158 and 132. We have two sides and we have the angle between them, so we have enough information to get the area. So the area of triangle ABC is going to equal half times 158 times 132 multiplied by sine 42.1. So the area for the first shape is 6,991.2. And then we do the same process for triangle ADC. So our given information here is we already got angle A here as 35.8. We have this angle here is 116. We have 132 and we have 86. So in order to get the area, you need two sides and the angle between them. So the easiest approach would be to calculate this angle here. And this angle is equal to 180 minus the sum of the other two angles, 116 plus 35.8. So let's figure this out. 116 plus 35.8. This gives us 151.8. And then 180 minus the answer. 180 minus 151.8 gives us 28.2. So this angle here is 28.2. And we can use it to find the area of the second triangle. Area of triangle ACD is equal to half multiplied by 132 multiplied by 86 multiplied by sine the angle in between, which is 28.2. And we figure this out. So 0.5 times 132 times 86 times sine 28.2. This gives us 2,682.19. So 2,682.2. And then the area of the field would just be the summation of the two areas. So 6991.2 plus 2682.2. And this gives us the final answer, which is 9,673.4, or you can write it as in three significant figures. It would be 9,680, and 70. This would be the three significant figure approximation of it. Both of these, I think, would be okay. So 9,670 is correct, or anywhere in between 9,669 to 9,676. This would all depend on the approximations used when finding sine and cosine and so on. So it's not a big deal. And then finally, we are told the bearing of D from A is 70. Find the bearing of A from C. So the bearing of D from A, this would be this angle here. This angle here. This black angle is basically equal to 70. And of course, the first thing that should come into our minds is we have many overlapping angles here. So it would be a good idea to try to figure out each individual angle. So let me make this a bit clearer by drawing it outside. So we have this big angle here, and then we have a dashed line here that goes this way, and we have a north. We have C here, we have D, we have A, and B. So the bearing of D from A would be from the north clockwise to the line AD. So it would be this angle here. So this angle here is 70. But we already know that this part is 35.8. So we can get the other part by subtracting 70 minus 35.8, which would give us 34.2. Now we have this small angle here. We also know from the previous part of the problem that angle A in total is 42.1. So this angle here is 42.1. So we can get this remaining part here as well. We might need it, we might not, but we can just subtract 42.1 minus 34.2, and this would give us 7.9. So the nice thing about doing this is that you now have each small angle, each individual angle, and you can use it to find whatever it is that you need to find, just in case, you never know. So find the bearing of A from C. So in order to find the bearing of A from C, we need to draw a north at C, and we need to find the angle that goes up until AC here. So how would we be able to do that? The most direct approach is to find this angle here and then to do 360 minus. So how would we find this angle? Remember that you have two norths. So this angle here is co-interior with this angle here. This angle between the north and AC, we already found it as 34.2. So if this angle is 34.2, then this angle would be 180 minus 34.2. So 180 minus 34.2 gives us 145.8. And then the angle that we want is the rest of the circle here. So 360 minus 145.8. So 360 minus 145.8 gives us 214.2. And this would be the answer to the final problem, problem E. So 214.2, excuse me. Let's check to make sure we're on the right track. Yes, 214.2 is the correct answer here. So in this problem here, we're told in the diagram BC is a vertical wall standing on horizontal ground AB. D is the point on AB where AD equals 58. The angle of elevation of C from A is 26. The angle of elevation of C from D is 72. Show that AC equals 76.7, correct one decimal place, and then calculate BD. Right, so in order to figure this out, let's first write down the givens. We are told that the angle of elevation of C from A, so basically A is looking up at C, and I want the angle with the horizontal. This angle here is 26, and then this angle here would be 72. Or let me write it inside. 72 right there. And we want to find AC. So how would we be able to find AC? One possibility here is to just find the angles in triangle ADC. That's one way of doing it. So this angle here would be 180 minus 72. So 108 basically. And then this angle would be 180 minus the summation of 108 plus 26. And 108 plus 26 is 134. So 180 minus 134 would be 46. So this angle here would be 46. Now, in order to find AC, we can simply use the sine rule. So let's call AC X. And then we can use the sine rule. X divided by sine 108 equals 58 divided by sine 46. We cross multiply. So X sine 46 equals 58 sine 108. We divide by sine 46. So X equals, and then we just evaluate this. So 58. I would recommend that you evaluate the numerator first. So 58 sine 108. And then you press equal. And then you divide the answer by sine 46. So as not to get wrong results from the calculator. So X here would be 76.68 or just 76.7. So since this is a show that, it would be a good idea to write 76.68 and then X equals 76.7. Just to show that we got the exact answer and then we approximated it to get the final answer here, which they require. Next, we're required to calculate BD. So how would we calculate BD? A good idea would be to try to figure out the height BC first. And we're able to do that now that we have X. So let's look at the big triangle. Let's look at triangle ABC first without the CD part. If we look at triangle ABC, we now have the hypotenuse, which is 76.7. And we have this angle here, which is 26. So can we get the height? Of course we can. Because sine 26 equals opposite over hypotenuse. So let's figure this out. I'm sorry for the lack of space. I'm just going to rewrite it on the right. So we said that sine 26 equals h over 76.7. We cross multiply. We get 76.7 sine 26 equals h. So h equals, and you use your calculator, 76.7 sine 26, 33.6. Now that we have h is the height, which is basically side BC, this side here. So this side here is now 33.6. They want BD, so we can use the small triangle here, seeing that we already have angle 72. And we can only say tan 72 equals opposite, which is 33.6, over adjacent, which is x. And then we cross multiply. X tan 72 equals 33.6. X equals 33.6 divided by tan 72. So 33.6 divided by tan, excuse me, tan 72. This gives us 10.9, which should be our final answer. So let's check the marking scheme. 10.9 is in fact the final answer here. And we're on the right track. So moving on, this seems to be correct. In this problem, it says the diagram shows some distances between Mumbai, Kathmandu, Dhaka, and Colombo. Angle CKD equals 65. Use the cosine rule to calculate distance CD. So this is a direct application. The opposite side here is C, and we say C squared equals 2380 squared plus 680 squared minus 2 times 2380 times 680 times cosine 65. And it would be a good idea to put these in big parentheses like this. So on the calculator, you write 2380 squared plus 680 squared minus, and then you open brackets, and then 2 multiplied by 2380 multiplied by 680 multiplied by cosine 65. And you get a very big number. So you just get the root of the answer. And you find that C is equal to 2181.48, which is approximately, to 3 significant figures, 2180. So now that we have the distance CD, we can write it down on the drawing. We have here 2180. Angle MKC equals 40. Use the sine rule to calculate the acute angle KMC. So right now we're supposed to figure out this angle here, KMC, using the sine rule. Of course, we have the side and the opposite angle and the side and the opposite angle. So this should be pretty straightforward to figure out. Let's write it down. So here we have 1560 over sine 40 equals 2380 over sine x. We cross multiply. So 1560 sine x is equal to 2380 sine 40. And then we divide by 1560. So you have 2380 sine 40. And then equals, and then you get the answer, and you divide it by 1560. And then you do shift sign answer. So of course, we don't have this anymore anyway, so x equals 78.7 degrees. Let's check the marking scheme to make sure we are on the right track. Yes, the answer to B is 78.7. Let's write it down. So we no longer need these lines. Let's just write 78.7 here. C says the bearing of K from M is 50. Find the bearing of M from C. So the bearing of K from M, we take the letter that comes after the word from, and then we draw the north at this letter, which is M, and we find the clockwise angle between the north and the line that joins the two letters. So the two letters here are K and M. So we want the angle between the north and the line KM. And this angle here is given to be 50. So this angle here is 50. And then we want the bearing of M from C. So how would we get the bearing of M from C? First of all, we would have to draw a north at C and then move clockwise until we get to MC, to the line MC. Now, of course, this angle is very weird, but the idea is to first get this angle theta here, and then you do 360 minus theta. So how would we get theta? Theta is pretty simple. This angle and theta are co-interior angles. So their sum is 180. So you can write a very simple equation here. 50 plus 78.7 plus theta equals 180. And you can figure out theta. It's quite straightforward. So 180 minus the sum of the other two angles. 50 plus 78.7. And you get 51.3 for theta. So the required angle here would be 360 minus 51.3. And you get 308.7. This is the required bearing. Which is approximately, of course, 309 to three significant figures. But anyway, even 308.7 is correct. So moving on, our final problem in this video. The diagram shows a field A, B, C, D, E. Calculate the parameter of the field. So in order to calculate the parameter of the field, we need the sum of the sides. We already have 3 of the 5 sides that we need because the parameter means that you're walking around the shape. So we have 50 plus 100 plus 170 but we still have unknown sides, which are x and y. So we need to figure out x and y in order to find the parameter. So x is straightforward because it belongs to a right triangle. We can create a Pythagorean theorem equation by saying, of course, let me highlight the triangle first so that you're on track. This is the triangle we're looking at. X squared plus 150 squared equals 170 squared. So x squared equals 170 squared minus 150 squared. So x equals root of 170 squared minus 150 squared. Of course, some people prefer using this step directly by simply minusing the hypotenuse minus the other side. This would work. You don't have to reach this step using the other previous 2 steps like I did. I just use the longest method so that everybody is on track. So anyway, here you have root of 170 squared minus 150 squared, which is 80. So x here is 80. And we substitute x for 80 here. Next, we need to find y. Y is also straightforward because, again, it belongs to a right angle triangle. So we're just going to do Pythagorean again. But this time y is the hypotenuse, so we're going to add rather than subtract. So y equals root of 50 squared plus 120 squared. And this gives us 130. So the parameter becomes very straightforward to compute. You just add these sides together. 50 plus 100 plus 170 plus 80 plus 130. And you get 530 as the value of the parameter. So let's check the answer. Yes, the answer to A is 530. So far we're doing okay. Let me erase, and I'm just going to write the values of X and Y that we got, 80 and 130 for future reference. This is 80, this is 130. Now we are required to find angle ABD. So angle ABD lies in a triangle that is not a right triangle, but we can use the cosine rule to get it. And the opposite side here is the 120, so this would be the negative side. So cosine theta equals 100 squared plus 150 squared minus 120 squared divided by 2 times 100 times 150. We evaluate the numerator. We get 18,100, so cosine theta equals 18,100 divided by 2 multiplied by 100 multiplied by 150, which would be 30,000. And then we shift cosine this fraction. And we get 52.89 for theta. So theta equals 52.9 degrees. Let's check the answer. 52.9 is correct. So let me write it down inside the drawing. I apologize for that. 52.9 is this angle here. In C, we are required to calculate angle CBD. So angle CBD belongs to a right angle triangle, so we can use SOHCAHTOA. This is our theta here. Let me quickly clear the screen to give ourselves some space. So for theta, for the new theta here, we use SOHCAHTOA, and you actually have the 3 sides, so you can use whichever ratio you want. I'm just going to go with cosine theta, I guess, for no particular reason. Any of them would work. Cosine theta would be the adjacent, which is 150, over the hypotenuse, which is 170, just in case you're not clear. Since this is theta, this would be the adjacent, this would be the hypotenuse, and this would be the opposite. I normally prefer to use the values that they gave us rather than the values that I got, just in case my answer was wrong. If I have values from the question, I prefer to go along with them instead. So cosine theta equals 150 over 170. We just shift cosine this fraction. and you get 28.07 or 28.1 to 3 significant figures. Let's check the answer. 28.1 for CI is correct. Let's write it down inside the drawing. And then we move to CII, which says the point C is due north of the point B. Find the bearing of D from B. So the bearing of D from B means that I draw the north at B. And this is already drawn because they said C is at the north of B. And I move clockwise till I reach the line BD. So I'm looking for this angle here. So in order to find this angle here, all you have to do is, this seems pretty simple. You just have to do 360 minus 28.1. So 360 minus 28.1. And this gives us 331.9. And this seems to be the correct answer as well. In the final part of the problem, we're required to calculate the area of the entire field. So again, we have to calculate the area of each triangle. So the area of the first triangle here, area of triangle EAD, would be half base times height, because this is pretty simple. So half times 50 times 120. And this equals, I'm using my calculator to evaluate it. So this equals 3,000. And this is the first area that we want. And then the second area would be area of triangle. I'm going to start with BDC because it's also simpler. The triangle on the right, because this is a right triangle, so it's also easy to compute. So half times base times height. Base and height are the two sides that are not the hypotenuse. So we're going to exclude the 170. We're going to take the 80 and the 150. If you notice, in both of these triangles, I took the sides that were not the hypotenuse. 120 and 50 for the first, 150 and 80 for the second. I excluded the hypotenuse in both cases because it's half base times height. So 0.5 multiplied by 80 multiplied by 150, that gives us 6,000. So the area here is 6,000. And finally, excuse me, we want to get the area of the middle triangle. This is not very difficult. It's just not as straightforward because you have to use the sine rule as opposed to half base times height. So you have two sides and you have the included angle between them. The included angle is 52.9. So we can just use area of triangle BAD equals half multiplied by 100 multiplied by 150 multiplied by sine 52.9. So half times 100 times 150 times sine 52.9. This gives us 5,981.879, so 0.9, or you can actually approximate to 3 significant figures, and this would actually be 5,980 to 3 significant figures. Now we want the answer in hectares. So first, let's get the total area. So the total area would simply be the summation of the three numbers we obtained, which are 3,000 and 6,000 and 5,980. So the total area is 14,980. And they want the answer in hectares. We don't necessarily know what a hectare is. We just use the scale that they gave us. So hectare meter squared. This is a ratio problem. This is 1, this is 10,000. Our answer is in meters squared. So we want the answer in hectares. We cross multiply. So we simply divide our number by 10,000 and we get here 1.498. So roughly 1.5 hectares. Let's check our answer. Yes, either 1.5 or 1.498 would work for this question, which brings us to the end of our video. I hope this has been beneficial. Thank you for watching.